Welcome students, how are you? Today we have the topic electronic displacements in covalent bond. This is the electronic displacements in covalent bond. First of all, certain displacements occur in covalent bond depending upon when we attach any electronegative group or when we attach any atom having more electronegativity than that of the atom. At that time the more electronegative atom displaces, it withdraws electron towards itself. At that time certain displacements occur. There are certain displacements already I have written here, like there is inductive effect, electromagnetic effect. In electronic displacements I already right now said that whenever an highly electronegative atom, like for example I am giving example like CX is any covalent bond, okay. If I will put here X is more electronegative than that of the carbon, if X is more electronegative atom than that of the carbon, then the X will withdraws electron, bears negative charge, and carbon will lose electron, bears positive charge. This displacement of electron by attaching more electronegative atom to this carbon is called electronic displacement. Electronic displacement takes place only when there is attachment of high electronegative atom. For example, if I will write here X is more electronegative, more electronegative. So this X will withdraw electron towards itself. This X will withdraw. It will withdraw electron. Withdraw electron towards itself. When it withdraws electron towards itself, as a result of this, X will achieve negative charge, and carbon will achieve positive charge. This displacement of electron and appearance of negative and positive charge is called electronic displacements. This displacement of electron when X, which is more electronegative than carbon, is attached is called electronic displacements. It is always when it is more electronegative atom. Anytime if carbon is more electronegative than X, at that time, if X is more electronegative than X, at that time I will write, at that time C will achieve negative charge and X will positive charge. It is also called electronic displacements. So it is not only the X is more electronegative atom, sometimes it is carbon more electronegative atom. At that time the electronic displacement takes place like this. The arrow will write this, but in this case the arrow is like this. Arrow head represents displacement of electron. Here the arrow represents displacement of electron from X to carbon. This is here from carbon to X. It is not possible only that X is more electronegative. Sometimes carbon be more electronegative. Okay. Now there are types of certain. Now we will critically examine this concept. There are certain types of electronic displacements. Majorly, there is inductive effect, electromagnetic effect. Another is resonance, and third one I will write here. Third one is resonance. Third one is resonance, or you can have this another mesomeric effect is also called resonance effect, or we call it mesomeric effect. Then another, both same have types. Sometimes it is plus R effect, minus R effect, or in this class you have plus M effect, minus M effect. Just categorize it as I have written already there. Now we will discuss what is inductive effect. It is one of the electronic displacements. It is one of the type of electronic displacements. Now we have inductive effect. Inductive effect, I will first of all write some example here. CH3 single bond, CH2 single bond, CH2, and then I will write here X. X is any group, halogen. X is like fluorine, chlorine, bromine, and iodine. X is any electronegative group, any electronegative group. X is any electronegative group. Electronegative group. When X is any electronegative group, then it will withdraw electron towards itself. Okay? Why? Because the electronegative power of X is more than that of this carbon, because it is attached to this carbon. It is just an example like this, CX, and then the groups are attached like this, then this. If it more electronegative than that of the carbon, therefore these are sigma electrons. These are sigma electrons. These are sigma electrons. Okay? Sigma electrons. What is now inductive effect? When the more electronegative atom is attached to one of the carbon. I attach here this X, which is more electronegative. It can be fluorine, chlorine, bromine, iodine, whatever. When it is attached to this carbon, being high electronegativity, it withdraws electron towards itself, leaving positive charge on the carbon and negative charge on the X. Or in other statements, I can write the definition of this in this way. This flow or this displacement of sigma electrons takes place. Displacement of sigma electron takes place when high electronegative atom is attached to this carbon. When any group with having more electronegativity is attached to one of the carbon, as a result of this, displacement of sigma electron takes place, is known as inductive effect. So inductive effect is just displacement of sigma electron when high electronegative atom is attached to one of the carbon. So I will write here the definition. It is the displacement of sigma electron when high electronegative atom is attached to one of the carbon. So displacement of sigma electron is just inductive effect. Displacement of electron. But this displacement of electron can happen only when you attach high electronegative atom. If you attach here low electronegative atom, the displacement of electron will take place at that time from X towards this group. So it depends upon the group. If you have a high electronegativity like fluorine, chlorine, bromine, iodine, at that time the displacement of electron takes place towards that X. If it is lower, it has lower electronegativity than that of the carbon, At that time, the displacement of electron takes place from the X towards the carbon. It takes place towards the carbon, towards this chain. Now we have two types of inductive effect. Okay, inductive effect is I have already written here. Inductive effect can be +1 or it can be -1. That depends upon the type of group. Now we will discuss that what is plus and what is minus I. CH3X. X I will put here chlorine. So the compound will become CH3Cl. First of all, I will discuss plus I effect. I have written already example this. This compound is called chloromethane. This is called chloromethane. Okay. This chloromethane is now then, here there is Cl, there is carbon. Carbon is bonded with the chlorine atom. But we know chlorine is more electronegative than carbon. Therefore, this CH3 group, it will donate electron, or this chlorine, it will withdraw electron from the methyl group. Why? If I will write carbon is less electronegative than chlorine. Therefore, CH3 single bond Cl. Here I will write partial negative, del positive. Del positive means this CH3 withdraws electron. I will write that by arrow. Arrow indicates that it is this like. Arrow indicates that displacement of sigma electron. Displacement of sigma electron. इसका displacement हो रहा है. तो displacement of sigma electron here. Now what is now here plus effect actually mean? If a group, if high electronegative atom is attached to this group, if the carbon donates electron, if the hydrocarbon part donates electron or it releases electron, once high electronegative group is attached towards it, it is called plus I effect. Plus I means when it releases. In case if the electronegativity of Cl is lower than that of methyl, at that time the Cl will withdraw electron. At that time it will be a reverse. So if plus I means when this releases electron towards high electron. Matlab when high electronegative atom is attached to hydrocarbon part, at that time hydrocarbon part will release electron towards high electronegative atom. It is called plus I effect. Plus I effect means property of releasing electron. Property of releasing electron. Property of releasing electron when high electronegative atom, when high electronegative atom is attached to hydrocarbon part, hydrocarbon part. So I will write here that it means all, this is the CH3 group. CH3 group is also considered as alkyl groups. It is represented by R. CH3 group is also represented by R. R here means alkyl group. Alkyl group. In general, I will write a statement that all alkyl groups have plus I effect because they have releasing tendency of electron. They always releases electron. As we have already discussed about hyperconjugation. At that time I told you that CH3 shows hyperconjugation, or CH3 increases the electron density when it is attached with any group X. It means increasing electron density, it means it has a releasing tendency. So CH3 or C2H5 like CH3, this is methyl group, comma, CH3, CH2, this is ethyl group, this is methyl group, likewise propyl, butyl, these are all alkyl groups. These are called alkyl groups and they are represented by R. R can be anything, it can be CH3, it can be CH3CH2. As already told in plus I effect, these alkyl groups releases electron. They release electron when high electronegative atom is attached to them. When they release electron, they bears plus and minus. So I will write here that all alkyl groups have plus I effect because they have a releasing tendency. But here is another concept like this. If I will write this CH3, CH2, CH2, then Cl, like this. This is the alkyl part, this is the hydrocarbon part, and this is the halogen part. This has a higher electronegativity than that of this. Therefore, it releases electron. This releases electron. Releases electron. So here partial positive, double positive, triple positive, okay. As the distance between electronegative atom and carbon increases, this inductive effect decreases. For example, this carbon experience more inductive effect. This carbon experience more than that of methyl. At that time, the Cl will withdraw electron. At that time, it will be a reverse. So if plus I means when this releases electron towards high electron. Matlab, when high electronegative atom is attached to hydrocarbon part, at that time hydrocarbon part will release electron towards high electronegative atom. It is called a plus I effect. Plus I effect means property of releasing electron. Property of releasing electron when high electronegative atom is attached to hydrocarbon part. So I will write here that it means all, this is the CH3 group. CH3 group is also considered as alkyl groups. It is represented by R. CH3 group is also represented by R. R here means alkyl group. In general, I will write a statement that all alkyl groups have plus I effect because they have releasing tendency of electron. They always releases electron. As we have already discussed about hyperconjugation. At that time I told you that CH3 shows hyperconjugation or CH3 increases the electron density when it is attached with any group X. It means increasing electron density, it means it has a releasing tendency. So CH3 or C2H5 like CH3, this is methyl group, comma, CH3, CH2, this is ethyl group, this is methyl group, likewise propyl, butyl, these are all alkyl groups. These are called alkyl groups and they are represented by R. R can be anything, it can be CH3, it can be CH3CH2. As already told in plus I effect, these alkyl groups releases electron. They release electron when high electronegative atom is attached to them. When they release electron, they bears plus and minus. So I will write here that all alkyl groups have plus I effect because they have a releasing tendency. But here is another concept like this. If I will write this CH3, CH2, CH2, then Cl, like this. This is the alkyl part, this is the hydrocarbon part, and this is the halogen part. This has a higher electronegativity than that of this. Therefore, it releases electron. This releases electron. Releases electron. Releases electron. So here partial positive, double positive, triple positive. Okay. As the distance between electronegative atom and carbon increases, this inductive effect decreases. For example, this carbon experience more inductive effect. Inductive effect. This carbon experience more, it experiences stronger inductive effect, this carbon. Why? Because it is directly attached with the chlorine atom. But this carbon does not experience as much inductive effect as this. And after that, this carbon experiences least inductive effect. Least inductive effect. Why? Because the distance between this carbon and this halogen is higher. So as the distance increases between halogen and carbon, this inductive effect decreases. So I will write here, inductive effect decreases with the distance. Okay? I will write here, inductive effect decreases with distance. Inductive effect decreases with distance. मतलब inductive effect inversely proportion distance. Higher is the distance, lesser is the experience of inductive effect. Okay, because more the distance between halogen and carbon, lesser is the inductive effect. Number one. Number two, this effect is not temporary. This is the permanent effect. This inductive effect is permanent effect. Permanent effect. Okay. What does that mean? It is a permanent effect. Matlab, when this carbon is when this halogen is here removed, when this halogen is removed here, this positive charge will disappear then. If it is continuously attached with here, this positive charge never disappears there. Because these hydrocarbon always have a tendency to displace, to release the electron. One is this chlorine is released here, the inductive effect cancel out. Means this is permanent effect. Positive charge remains on the carbon as long as this halogen atom is there. It's a permanent effect. It's not a temporary effect. This is the permanent effect. Coming to that plus I effect we are talking, these are two concepts here which are very important to mention. I have written that all alkyl groups have plus I effect. Plus I effect. This plus I effect has one of the application. It decides whether the acid is strong or weaker. So one of the application of this plus I effect is application of this inductive effect I will write. For example, I will write three acids. Inductive effect sometimes it decides whether the acid is strong or weaker. There is some example number one. If I will write two acids, CHCOOH, then I will write CH3COOH, then I will write CH3CH2COOH. It is anything that gives H positive. Acid is any substance that gives H positive when dissolved in water. Okay, acid is any substance that gives H positive. So acid is any substance that gives H positive. This is first thing. Okay. In three acids which will give H positive more readily is stronger acid automatically by definition. But this CH3 has plus I effect, means it will donate electron, because inductive effect means donation of electron, and it has a plus I effect. Plus I means when it donates electron, and minus I means when it withdraws electron. But I have written statement all alkyl groups have plus I effect. This CH3 is alkyl group. This CH3 is alkyl group. This CH3 CH2 it will also show plus I effect. The more inductive effect will experience acid number C. When it gives more, when it shows stronger inductive effect, it will increase the electron density here. When it increases the electron density here, the bond, when it increases the electron density here, the bond between O and H will become stronger. When the bond will become stronger, this H positive will not release more rapidly. Okay? So CH3, CH2 shows stronger effect. This CH3 shows weaker inductive effect than that of this. Therefore, it will releases electron more efficiently than that of this, means this is a weaker acid than that of this. Because acid is anything that gives H positive more readily. When it does not give H positive more readily, means this is a weaker acid. And this is the stronger acid as compared to this. But this is the strongest acid because it does not contain any alkyl group. So that means any acid containing alkyl group makes it weaker acid. Because alkyl group shows plus I effect, they releases the electron, that electron density increases on oxygen atom, owing to which H releases, H in releasing the form of H positive does not facilitate here. So means if the acid does not contain any alkyl group, is a stronger acid than that of acid which contains methyl group. So I will write here HCOOH is a stronger acid than that of CH3CH2COOH, this one, because this shows stronger plus I effect. When there is a stronger plus I effect, the H positive will not releases more strongly, more rapidly. But this, it does not contain any methyl group, therefore it is a stronger acid. So one of the application of inductive effect is relative strength of acidity. So in three acids, order is C is greater than A then B. So therefore C is strongest acid. After that, in between A and B, in between the order is like this, alphabetic order I have written here. A is stronger acid, then B, then C. I have written, I don't see here the alphabetic, sorry for that. A, B, C. The order is A, then B, then C. Means the weakest acid is propanoic acid. The weakest acid is propanoic acid because it contains ethyl group which has a stronger plus I effect. So here I will write some concept here, because CH3, CH2, COOH is weakest acid, because it contains CH3, CH2. This is ethyl group. And ethyl group has strong plus I effect. So stronger acid is that which does not contain any alkyl group. Okay? Stronger acid is that which does not contain any alkyl group. Stronger acid is that which does not contain any alkyl group. Therefore, the order is HCOOH is stronger acid, then CH3COOH, then CH2COOH. This is the weakest acid. This is the strongest acid. So when you have to discuss the relative strength of acidity on the application on the basis of inductive effect, it is like this. How stronger is the inductive effect, weaker is the acid. Absence of the alkyl group, stronger is the acid, because alkyl group will show, alkyl group shows plus I effect, releases electron, increases that electron density on the oxygen, the O and H bond becomes stronger, H will not release more rapidly, with the result the acid proves weaker. That is why this is a weaker acid, because this group has a stronger effect. This has the weaker, stronger inductive effect than that of this, and this does not contain any alkyl group. Therefore, this is the stronger acid. The order is like this: A, B, C. If it is A, B, C. If it is A, if it is B, if it is C. Number one, application number one of inductive effect. Okay, and second. We were on the plus I effect. And second is minus I effect. And minus I effect I have not discussed, but here there is a little definition. After that we will go application number second. Plus I effect means electron releasing property. Electron releasing group. For example, CH3X plus I effect. Okay. Here CH3 again X. This X withdraws electron from this X, CH3. X withdraws electron from CH3 as shown in this diagram. So I will show X has then minus I effect. So minus I effect means when it withdraws electron from the group, means it has a higher electronegativity. So this X can be fluorine, chlorine, it can be NO2, anything. It can be carboxylic acid, anything. But the electronegativity of X should be stronger than this. Otherwise, the electron displacement takes place from X into this. If the X is more electronegativity, the displacement of electron will be like this. So that means if the X is more electronegative, so at that time it has a minus I effect. For example, if I will write this example, CH3NO2. Okay, this NO2 it withdraws electron towards itself. It has minus I effect. Minus I effect. How minus I effect? If I will draw the structure N double bond O, O. If I will draw here, write this. The new structure will become CH3 single bond N, positive, O negative. This N positive will withdraw electron from CH3 because as it is the high electronegative atom, number one. Number two, it has a plus charge. This plus charge, nitrogen will not bear positive charge. So it will withdraw electron from CH3. When it withdraw electron towards itself, it is called a minus I effect. So property of withdrawing electron towards itself is known as minus I effect. Property of withdrawing electron towards itself. Minus I effect. Here, property of releasing electron is called plus I effect. Here it is withdraw, here it is donate. Property of releasing is called plus I, and minus I property of withdrawing. So this NO2 will always withdraw. I will show arrow like this. This has then negative, this has then positive. Positive means release, negative means gain. When NO2 withdraws electron, it is minus I. So minus I and plus. Minus is opposite to that of plus. If plus is releasing, minus is withdraw. Okay, then we were discussing about applications of inductive effect. Number one application, relative strength of acids. Second is relative strength of bases. Application number second, relative strength of bases. Just like in acids, we have discussed that more the number of alkyl groups attached to the carboxylic acid, lower is the acidity, and lesser is the number of alkyl groups attached to the carboxylic acid, stronger is the acid. So that is why methanoic acid is a stronger acid than that of ethanoic acid, because in methanoic acid there is no alkyl group. When there is no alkyl group, there is no inductive effect, means H positive will release rapidly. But in case of bases, I will write three bases: CH3NH2. This is called methylamine. Second is CH3NH, then here CH3, and third one is CH3 single bond N, CH3, CH3. As you have recognized, I am releasing H and place there CH3. This is 1 degree amine, because it contains only one methyl group. This is 2 degree amine, because it contains two methyl group, and this is 3 degree amine, because it contains 3 methyl group. On the base of inductive effect, if I will discuss which is the stronger base, because inductive effect is the application number second, relative strength of base, where where inductive effect applies. In acids, we have discussed that. After that, relative strength of bases. Now we will discuss which is the stronger base on the base of inductive effect. On the base of inductive effect, I have discussed acid, which is the stronger acid. Now I will discuss on the base of inductive effect, which is the stronger base. Here I will write 1 degree amine is here, 2 degree, it is 3 degree. If you analyze, this contains only one OR group. This contains 2 OR group. And this contains 3 OR group. What is base? First of all, we should know what is the base. After that, we will discuss which is the stronger base. Base is anything that has property of releasing tendency of electron. Base is anything that gives electron. Actually, base is anything that gives electron. Anything that gives electron. So here, which will give electron more rapidly is considered as stronger base. But that depends upon which have more electron density, because that species will give electron more efficiently, having more electron density. If you analyze here is stronger inductive effect. Inductive effect by 3 alkyl groups. Here is inductive effect by 2 CH3 groups. Here is inductive effect only by 1 CH3 groups. Here electron tendency, electronic concentration increasing tremendously as it contains 3 methyl groups. Because here the inductive effect is 3 times. 3 times will CH3 electron gives, because it will release. So the electron density increases here tremendously. Electron density increases increases strongly, because it contains 3 alkyl groups. It contains only 2 alkyl groups, but it contains only 1 alkyl groups. More the number of alkyl groups attached with the nitrogen atom, higher is the basicity. That is why the order is, if you analyze, the order is here. I will write first order: 3 degree, 2 degree, 1 degree. What I mean that this 3 degree amine contains 3 CH3 group, but alkyl group shows plus effect. Means that here nitrogen has high electron density because it receives electrons from 3 methyl groups simultaneously. Okay, this nitrogen atom receives electrons from 2 methyl groups only. This nitrogen atom receives electron only from 1 methyl groups. It means the higher electron density on this nitrogen. When it has high electron density more on this nitrogen, it will prove as stronger base. So because base is anything that gives electron, this will give electron more strongly than this, and this is the weakest base. Okay, this is the weakest base. Why the order is 3, 2, 1? Because it depends upon alkyl groups. And here the application inductive effect plays here dominant role, because if I will here write NO2, at that time this is the weaker base, because NO2 withdraws electron towards itself. But alkyl group donates electron towards more electronegative, which is a nitrogen. For example, if I will write here CH, यहाँ NO2, then NO2, then NO2. This is the weaker base. This is the weaker base, because this NO2 withdraws electron, withdraws, because it has a minus I effect. Plus I effect increases basicity, but plus I effect decreases acidity. It is the reverse of that. Because I have discussed in acidity, the more the number of alkyl groups are attached, lower is the acidity. That is why propanoic acid is a weaker acid than that of methanoic acid. But in base it is reverse. More the number of alkyl groups are attached, higher is the plus I effect. When higher is the plus I effect, more is the electron density. When more is the electron density, it proves stronger base. So I will write here the statement like this, which will memorize the concept. More the number of alkyl groups are attached to nitrogen atom. Just like here, this 3 degree contains more alkyl groups. I am writing that more the number of alkyl groups are attached to nitrogen atom, higher is the basicity. Higher is the basic character, I will write. In short, higher is the basic character. If I will remind you well that it is the reverse of acidity, in reverse of acidity, because in that case, more the number of alkyl groups are attached to the carbon, lower is the acidity, because at that time the hydrogen will not release, it will not break up. But here the nitrogen will give more electron density if it is attached by more number of alkyl groups, because more number of alkyl groups, more is the inductive effect. More is the number of alkyl groups, more the number of also alkyl groups attached, alkyl groups, more is the plus I effect. When more is the plus I effect, higher is the basicity. Higher is the basicity. Okay. It is the relative order is 3 degree, 2 degree, 1 degree. That is why. On the basis of this concept. Okay. Now we have also we will write, this is another which has a plus I effect, which has a minus I effect. I will write that. Here I will write electron donating groups, EDG. Electron donating groups donating groups. Then second is EWG. It is electron withdrawing groups. It is electron withdrawing groups. Electron donating groups are like, in this section, all alkyl groups are electron donating groups. All alkyl groups means CH3, C2H5, likewise methyl, ethyl, propyl, C3H7, all alkyl groups. These all have a plus I effect. Electron donating groups. These all electron donating groups have plus I effect because they have a releasing tendency of electron. Electron withdrawing groups, here comes X. X is fluorine, chlorine, bromine, iodine. Here also CN, cyanide, carboxylic group, nitro group, etc. All they have electron withdrawing groups, means they withdraw electrons. Withdraw electron towards themselves. For example, I will show you how CN withdraw electron. The structure of the CN is like this, cyanide. This is called a cyanide. If I will draw the structure here, this is C double bond N, negative, positive. If this cyanide is now attached here CH3, this positive is electron deficient. When it is electron deficient, it withdraws electron. It will withdraw electron like this. Because this carbon does not bear positive charge, so it will withdraw electron from CH3. Proves that it is an electron withdrawing group. Okay. Again, if I will attach here CH3COOH, this carboxylic group, what it will do? If I will draw the structure CH3C double bond O, then OH. If I will draw like this, the next structure will become CH3 single bond C, positive, negative, OH. Again it will withdraw electron from carbon. Proves it is electron withdrawing group. So depending upon withdrawing and tendency or donating tendency, we have electron donating, electron withdrawing. In general, all electron donating groups have plus I effect. All electron withdrawing groups have minus I effect. And this is when you have to recognize whether the group have a plus I effect or minus I effect. You show there, you have to build a concept regarding what is EDG and what is EWG. It is electron donating, means when there is attached alkyl groups, means ki it is plus I, means this is minus I, plus I, because you have to at that time draw the structure. Again, if I will draw the structure of this CH3N double bond O, this is the structure of NO2 in bonding. In bonding we have these structures. If I will like this, I will write another structure. It is CH3N positive, O negative, then this. Again this will withdraw electron. This all withdrawing groups. So depending, analyzing electron donating electron which has a plus I, which has a minus I, it is like this. All groups are like this. All these groups are like this. Okay. Another is, I will write two compounds. One is CH3 and this benzene. This is called methyl benzene. Common name is toluene. Common name. Okay, if I will draw another compound here, this is actually NO2. It's called nitrobenzene. this nitrobenzene, this is methyl benzene. If you here see, if I will like this, the new structure will become this is electron withdrawing, this is electron donating. Means that now nitrogen has a positive charge, so it will withdraw electron towards itself. But this methyl is electron donating, it will increase electron density on nitrogen, on benzene. Makes benzene more activated. Here it will withdraw electron, NO2 withdraw electron from benzene, makes it deactivated. Should I say electron withdrawing groups are deactivating groups, electron donating groups are activated groups? Deactivated towards H positive species, but this encourage H positive because this is electron donating group. When you donate, electron density increases on benzene, this H positive will attack here easily. But here H positive, this will benzene electron move towards cell, and here the structure is again here new structure. This is positive, this is double bond, this is negative, and this is positive. Means that H positive here does not attack, no attack, because this NO2 makes this benzene deactivated towards H positive attack. Means H positive do not attack on this benzene when it is being attached by electron withdrawing group, but this H positive will easily attack on the benzene when this is attached by this group, electron donating group, because plus I effect increases. Plus I effect deactivates the benzene group. Plus I groups activates benzene. Like methyl benzene is more activated. It activates H positive to attack on it because this needs electron. Minus I effect deactivates the benzene. This NO2 H positive attack on benzene is no feasible, but when H positive attacks on benzene, it shows fast reaction. So this was about all inductive effect types: electron withdrawing, electron donating, relative Strangotha acids, relative Strangotha bases. In next video we will discuss